Welcome to The Explainer. Today, we are really diving into the science behind the viral video. We're going to look at how one company, Higgsfield, is using AI to take a simple idea, or get this, even just a web link, and turn it into social content that's literally engineered to go viral. So let's just start with a question that I think plagues just about every creator and marketer out there. Why is it so incredibly hard to make a video that looks so simple, so effortless, but just blows up and goes viral? I mean, you see them every single day on TikTok and Reels, right? But trying to actually crack that code yourself, it feels next to impossible. Well, the answer, as it turns out, comes down to this set of kind of invisible social rules. Yeah, they're not written down anywhere, but they are secretly dictating what we watch and, more importantly, what we scroll right past. And honestly, getting them right is the entire difference between a viral hit and a total dud. And we're talking about really subtle cues here. Things like how fast you hook the viewer in, those first 3 seconds. What's the rhythm of the cuts? What kind of camera motion are you using? It's all about creating a video that feels perfectly native to whatever the current trend is. That right there, that's what separates the viral hits from the flops. Okay, so this is the exact problem that a company called Higgsfield is setting out to solve. They're what's called a generative media platform, and they are building this incredibly intelligent system on top of really powerful AI. Think OpenAI's language models and the latest video generators. And their whole goal? It's to give one person, a solo creator, the power of an entire creative agency. So the real challenge, the core of the problem, is figuring out how to translate our vague human ideas into a set of concrete instructions that an AI can actually understand and follow. That's the crucial bridge they had to build. And, Higgsfield's CEO, Alex Mashrabov, he just puts it perfectly. He says, we don't think in technical terms, right? We don't give instructions like a shot list. We think in feelings. We say things like, hey, make it more dramatic, or I want this to feel really premium. And this right here is that exact translation gap in action. On one side, you've got our human desires, all that emotion and intent. And on the other side, you've got what the AI actually needs. These super precise rules for shot timing, for motion, for what to focus on visually. 2 totally different languages. So, Higgsfield's solution to this is something they call a cinematic logic layer. The best way to think about it is like an expert creative translator. It takes your intent, that feeling you're going for, and then it uses AI to build out a super detailed, concrete video plan. And this is all before a single frame of video is even generated. It's the thing that finally bridges that gap between us and the machine. And this is what leads to their next really big idea. What if you could take all the guesswork out of going viral? What if you could turn it into a repeatable, scientific system? See, for Higgsfield, virality isn't some kind of magic lightning in a bottle. It's math. They track this really key metric they call share velocity. Now, this is the tipping point, right? It's where people go from just liking a video to actively sharing it. It's that moment when the shares start to outpace the likes. That's when you know a piece of content has stopped being passively consumed and is starting to spread all on its own. So how do they capture this? Well, their AI goes to work analyzing literally thousands of top-performing videos. It's looking for those recurring patterns, those successful structures. Then, it distills all those findings and encodes them into a library of video presets. And because social media trends change like in the blink of an eye, their system is creating around 10 new presets every single day just to keep up. So, the big question, does it actually work? Oh yeah, the results are pretty stunning. Videos that are made with this system see a 150% increase in that share velocity metric. That means people aren't just watching, they are hitting that share button way more often and way, way faster. And it's not just about shares. The system also leads to a 3 times higher rate of what they call cognitive capture. Now, in simple terms, that just means the videos are stickier, they're more memorable, they stay in the viewer's mind, and are much more likely to influence what that person does next. I mean, that is a massive, massive impact. Okay, so we've talked about all this complex stuff happening in the background, but how does it all actually work for a user? Let's take a look at the actual workflow. They have this feature called Click to Add, and it makes the whole process incredibly simple. I mean, all a user has to do is paste in a link to a product page. That's it. From there, the AI analyzes the whole page to figure out the product, the brand's intent, everything. Then the system automatically maps all that info to a trending video preset. And boom, the video model generates the final ad, completely ready for social media. Now, behind the scenes, the system is acting like a really smart project manager. It's not just using one giant AI for everything. Nope. Instead, it's routing different tasks to different models based on what they're good at. So for precise, predictable jobs, it'll use a faster, more focused model. But for those really complex interpretation tasks that need deep reasoning, it calls in the big guns, a larger, more powerful model. And their CTO, Yerzat Dulat, explains it this way. It's not about finding the one best model. It's about understanding their behavioral strengths. Some AI models are just great at being precise, while others are amazing at creative interpretation. It really is about using the right tool for the right job. So when you pull all of this together, what you're looking at is a really fundamental shift in how creative work is going to be done. And not in the distant future, I mean in the very near future. What this means is that the very nature of being a creator is changing. The job is shifting away from worrying about all the technical details. The software settings, the editing timelines, all that stuff. As AI starts to handle the execution, it frees up creators to focus on what actually matters: the story, the tone, the message. We're basically moving from being tool operators to becoming true creative directors. And all of this leaves us with one final and, I think, fascinating question. As AI continues to take care of more and more of the technical how behind creating things, all those barriers to entry, they're just falling away. The only real limit that's left is our own imagination. So the question is, what stories will you tell? So OpenAI just announced something pretty huge, a new initiative that's all about reshaping education, not just in one country, but on a global scale. And you might be asking, why now? Well, it's because we're all staring down one of the biggest challenges of our time. How do we get ready for a world that's completely powered by AI? To really get why this initiative is so critical, we first need to understand the core problem that it's trying to solve. And that problem has a name: capability overhang. Now, it sounds a little technical, but the idea is actually super simple. We've got these incredibly powerful AI tools, right? But there's this massive gap between what they can do and what most of us are actually doing with them. It's kind of like having a Formula One race car in your garage, but only using it to get groceries. The real power, the real transformation only happens when people know how to push that technology to its limits. And this isn't just some abstract idea. This overhang has a huge impact on the real world, especially our jobs. Get this. Projections show that by 2030, nearly 40% of the core skills people use at work today are going to change. And guess what's driving that change? Yep, almost all of it is AI. This isn't some far-off future we're talking about. This is happening, like right now. It's exactly that urgency that's behind OpenAI's new program, called Education for Countries. It's their big, direct response to this challenge of getting the workforce ready for what's coming. So what's the big idea here? Well, the crucial thing to understand is that this is not just about handing out some software to schools. No, this is about a deep partnership. OpenAI is working directly with governments and universities to actually weave AI tools, training, and research right into the fabric of their education systems. It's a systemic approach, The whole point is to close that capability gap and make sure the next generation doesn't just know about AI, but knows how to use it. Okay, so that's the big vision. But how are they actually going to pull it off? Well, the whole program is built on 4 key pillars that work together to create this whole new learning ecosystem. So first up, you've got the tools themselves, like giving schools access to things like ChatGPT EDU. Second, there's the research. They're going to work together to figure out what impact AI actually has on learning. Third is training and certification for both students and teachers. And finally, number 4, they're building a global network so everyone can share what works and what doesn't. All right, so that's the plan on paper. But what does it look like when the rubber meets the road? Let's take a look at Estonia, a country that is absolutely all in on this, to see how it works in the real world. You see, Estonia isn't just dipping its toes in the water here. Oh no, they have dived in head first. They've rolled out AI tools like ChatGPT Edu across their entire nation. We're talking every public university and secondary school. It's a really bold national-level commitment that could totally set the standard for everyone else. And the scale here is just wow. In just its first year, the program has already reached more than 30,000 students, teachers, and researchers in Estonia alone. That's a massive, real-world experiment playing out right now in AI-driven education. This quote from Ivo Visak, the guy leading the charge in Estonia, really just nails the whole mission. He says, it's not about using AI to just spit out answers faster or memorize more stuff. No, it's about strengthening how we learn. It's about building those critical thinking and problem-solving skills. That's how you really close the capability overhang. So let's zoom out for a second. This whole initiative, it's bigger than just one company or a handful of countries. It's really part of this much larger conversation that we're all having about what the future of learning and work is going to look like. So to wrap it all up, what are the big things to take away from this? Well, first, the problem. AI is changing the workforce, and it's happening fast. Second, the solution. Education is absolutely the key to closing that capability overhang. And third, the action. This OpenAI program gives us a real blueprint for how countries can start integrating AI into their education systems and do it right. And all of this leaves us with one last really big question to think about. For, centuries, education has been about teaching students how to find the right answers. But what happens in a world where an AI can give you the answer to almost anything instantly? What is the role of the student then? What becomes the new focus of learning? That's a question we're all going to be figuring out together in the years ahead.
So, all right, today we're diving into something called AssetOpsBench. It's a fascinating new benchmark that's giving AI a much-needed and pretty serious reality check. Let's just kick things off with a huge, high-stakes question. Are AI agents really ready to run our critical infrastructure? I'm talking about the heavy-duty stuff, power grids, massive data center cooling systems, the things our modern world literally cannot function without. We've all seen AI do some incredible things in what you could call the AI playground. It can write code, browse the web, draft emails like a champ. But this slide really shows the massive gap between that world and, industrial reality. Managing physical hardware, preventing catastrophic failures, and coordinating human teams, that is a whole different ballgame with way, way higher stakes. And this gets us right to the heart of the problem, what we can call AI's industrial blind spot. It turns out the way we've been testing AI agents might be preparing them for the wrong job entirely. Think about it for a second. Most AI benchmarks are all about single, isolated tasks. But industrial operations, they're not neat and tidy. They are complex, messy, interconnected systems where multiple agents, both human and AI, have to work together flawlessly. Our current tests just don't capture that high-stakes, team-based reality at all. And that is exactly where AssetOpsBench comes in. It's a completely new kind of framework, a new kind of test that's been built from the ground up specifically for the messy reality of industrial operations. So what is it, really? Well, to put it simply, AssetOpsBench is designed to test if an AI agent can manage complex industrial hardware, like the cooling systems for a massive data center. And the key here is its focus on two things most tests completely miss: multi-agent coordination, and of course, safety. And the scale of this thing is just huge. It is built on a foundation of 2.3 million real sensor data points. It includes over 4,200 unique work orders, covering all sorts of diverse and challenging scenarios. It incorporates 53 different structured failure modes. That's 53 known ways these incredibly complex systems can break down. And all of this data is woven into over 150 distinct scenarios, every single one of them validated by human experts to make sure it reflects the real world. Okay, so let's talk about the philosophy behind this test, because it's pretty clever. AssetOpsBench isn't just about pass or fail. It's actually designed so that failure itself becomes a feature, a really valuable source of information. So instead of just a simple score, agents are evaluated across these 6 qualitative dimensions. It's not just, did you get the job done? It's also, hey, was your data retrieval accurate? Did you actually check your work? Was the sequence of your actions logical? And maybe most importantly, was your reasoning clear and did you just make stuff up? This quote from the research paper just nails it. Understanding why an agent fails is often more valuable than a binary success signal. I mean, think about it. If a hospital's cooling system is about to go down, you need to know exactly why, not just get a simple yes or no notification. Okay, so the researchers built this incredibly rigorous, really realistic test for AI. Which brings us to the big question. How did today's top models, we're talking the best of the best, how did they actually do? Well, the results are pretty sobering.
Here are the numbers. They tested all the big names, GPT-4.1, Mistral Large, and Meta's Llama models. And as you can see, the top scores for planning and execution are kind of hovering in the high 60s and low 70s. But what do those scores actually mean in context?
It means this. According to the people who created the benchmark, to even be considered safe and reliable enough to deploy in a critical environment, an agent needs a minimum score of 85.
And the stark, unavoidable conclusion from the whole experiment? None of them passed. Not a single model they tested managed to reach that deployment-ready threshold. So the obvious question is, why? Why did these incredibly powerful AI models fall so short on this test? Let's unpack the key error patterns that the research uncovered.
This chart right here is incredibly revealing. Look at the top two reasons for failure: ineffective error recovery at over 31% and overstated completion at nearly 24%. Together, that's more than half of all the failures. So the agents are running into problems they can't fix, and then they're confidently reporting back that everything's fine. And that is a truly dangerous combination.
We can break this down even more. First, you've got the sounds right is wrong problem, where agents just claim success even though they failed. Second, teamwork is hard. Adding more agents actually made things worse. It multiplied the failures. Third, even when they were given the instruction manual with all the specific knowledge they needed, they really struggled to apply it correctly. And finally, when the data gets messy and ambiguous, which it always is in the real world, the success rate just plummeted by 34%.
And this slide just perfectly illustrates that teamwork problem. On its own, a single AI agent could get about 68% accuracy on a task. But the moment it had to coordinate with a team, that accuracy collapses all the way down to just 47%. The context sharing, the timing, the handoffs, that's where it all falls apart.
So, where does all this leave us? I know the results might sound a little discouraging, but they're actually incredibly valuable. For the very first time, we have a clear, data-driven map of AI's biggest hurdles in the industrial world. This isn't a failing grade. It's a detailed diagnostic report for the entire AI community. And that leaves us with one final critical question. Now that we know exactly what the test is, who's going to be the first to build an agent that can finally pass it?
All right, let's get right into it. Today, we're going to talk about a huge shift happening in AI, something called Agentic AI. The whole idea is moving past simple chatbots and really, truly unleashing a mind in the box. I mean, think about it. We've all used an AI that can write an email or maybe answer a trivia question. But what if it could actually do things? What if it could plan, use tools, and learn from its mistakes completely on its own? That's the incredible new world we're stepping into. And this image right here, it just nails the massive leap we're talking about. Over on the left, you've got your traditional large language model, or LLM. It's basically a closed world. It knows what it was trained on, and that's pretty much it. But on the right, you see the agentic system. That's not just a passive tool. It's an active partner that can use other software, think about its actions, and actually interact with the world to get a job done. Now, to really appreciate just how big a deal this is, we first have to understand the limits of the AI most of us use every day. They're incredibly powerful, for sure, but they are fundamentally a mind trapped in a box. This chart breaks down those limits perfectly. You see, traditional LLMs, they're passive. They just react to whatever you type. Their knowledge is totally fixed, frozen in time from when they were trained. They have zero memory from one conversation to the next, and they can't reach out and use external tools. It's a completely closed world. Agentic systems, on the other hand, just flip every single one of those limitations on its head. So the big question is, how do we break the AI out of that box? Well, the answer is a totally new way of thinking about intelligence: Agentic AI. And here's the core idea. Agentic reasoning basically reframes the AI from being a simple text generator into an autonomous agent. An agent that doesn't just think, it can plan, it can act, and most importantly, it can learn from its interactions with the world around it. Okay, this diagram here is basically going to be our guide for the next few minutes. It shows you exactly how agentic reasoning is built layer by layer. It all starts with a single agent's foundational skills. Then, that agent learns to evolve and improve itself. And finally, you can have multiple agents team up to form a kind of collective intelligence. So, let's dig into that first layer. Every agent's got to start somewhere, right? These are the fundamental abilities, the building blocks, that a single AI agent needs to operate autonomously and, actually be effective.
And it really boils down to these 3 key skills. First, there's planning, the ability to look at a really complex goal and break it down into smaller, manageable steps. Second, tool use. And this one is a game changer. It's the ability to call on other programs or APIs to do things the model itself can't, like crunching numbers or pulling from a specific database. And third, web search, the power to go out and get current, up-to-the-minute information from the internet.
And this is the part you really have to get. Using tools is the key that unlocks the box. It lets the agent completely overcome its built-in limitations. It's no longer stuck with old data, it can get live info. It's no longer bad at math, it can just use a calculator. This is literally how the AI starts to interact with the real world. But look, a truly intelligent agent doesn't just act, it learns from those actions. And this is where we move beyond that fixed knowledge into genuine self-improvement. The whole goal here is to create agents that actually get smarter over time. They aren't just one-and-done tools that execute a task and then forget about it. No, they are designed to build on their cumulative experience, constantly getting better at what they do. So how do they do it? Well, they use this powerful feedback loop. First, after the agent does something, it engages in self-reflection. It's basically critiquing its own work, asking, did that work? Why or why not? Based on that feedback, it starts replanning, adjusting its whole strategy. And finally, it'll retry the task, but this time with that new, improved plan. This is literally how it learns from its own mistake.
Of course, none of that learning would be possible without memory. Agentic memory allows the AI to store what happened in the past, both its successes and its failures. This persistent memory means it can actually update its own knowledge and remember what worked before, making it more and more competent with every task.
Okay, so we've got a single agent that can act and learn. That's already pretty cool. But now, what happens when you get a whole bunch of these agents to work together? This is where we see the most powerful layer of agentic reasoning: collaboration. And we're not just talking about adding their brain power together. Here, the intelligence of the system can scale exponentially. By forming a team, a whole collaborative ecosystem, these agents can tackle problems that are way too complex for any single agent to solve by itself. So how does an AI team even work? Well, you can give them specific roles just like a human team. You might have a manager agent that hands out tasks, a critic agent that reviews the work, and a tester agent that checks for any mistakes. They share what they know, they can debate different approaches to find the best solution, and they can even evolve together to become a better team over time. And these teams can be set up in different ways. In a centralized model, you might have one manager agent directing all the others. But in a distributed model, the agents work more like peers, collaborating in a kind of streamlined assembly line fashion. The best structure really just depends on the problem they're trying to solve.
Okay, this all sounds amazing in theory, but where is it actually being used? Let's look at how agentic AI is already making a real-world impact.
And the applications are already incredibly broad, touching almost every industry you can imagine. We're seeing agentic systems used in scientific discovery, helping analyze data and come up with new hypotheses. In robotics, they're helping machines interact with the physical world. They're showing up in healthcare, software development, finance, you name it. They can automate complex web research or even develop winning strategies in super complex games. And just to give you a sense of the sheer scale we're talking about, check this out. One system called Tool LLM was trained to use over 16,000 different real-world APIs. That is a massive toolbox, allowing it to perform an incredible range of tasks by interacting with all sorts of different software out there. So we're unlocking the mind in the box. We're giving it tools, memory, and the ability to work in teams. And that leaves us with one final and absolutely crucial question to think about. As these AI agents become more and more autonomous, how do we build the right frameworks to make sure they always work for us, aligned with our goals and our values? That's the challenge waiting for us just ahead.